Supersymmetry would be very helpful in many ways. It turns out to be right. When you have large mass ratios in a quantum field theory, heavy particles versus light ones, and playing the same sorts of roles, it's very difficult when you calculate to all the orders of perturbation theory, when you calculate fairly exactly what happens, it's very hard to keep those ratios large. The masses tend to approach each other. But this doesn't happen if you have broken supersymmetry, provided the breaking isn't too bad, provided the violation of supersymmetry isn't too serious. So there's this great hope among theorists that it will turn out to be true that there's broken supersymmetry, and not too badly broken either. That would explain why the theory tolerates these large ratios of masses. And maybe it's true that we have it, that we have supersymmetry that's broken but not too badly, in which case one should observe particles that are partners of the known particles with the opposite so-called statistics, the opposite behavior with respect to occupying the same state at the same time. The electron is an example of what we call a fermion. It's a particle such that two of them can't stand to be in the same state at the same time. The photon is an example of a boson, which loves to be in the same state as another boson. And of these two kinds of particles, fermions and bosons, what broken supersymmetry tells you is that for every known particle, there must be and so far unknown one to be discovered, which has the opposite behavior. So the superpartner of a fermion is a boson, and the superpartner of a boson is a fermion. And we have to look for those particles, and that's what's happening here. And who knows, maybe they're beginning to see one or two of them. But we have to wait for firmer results. Can't decide anything on the basis of rumor. We have to wait for seriously announced results.